Hi everyone! In this video, I would like to summarize what we have seen in this module and connect the content to the rest of the course. Previously, we saw that functions in FP are really limited. They can't throw exceptions, return different results at different times, or connect to external systems. FP might be awesome, but with these restrictions in place, it's impossible to write a real-world application. So FP developers found a workaround called I/O. An I/O is basically a piece of unevaluated imperative code. This means that we do manipulate code that will eventually interact with the external world. But because it's not yet executed, we don't break the functional programming requirements. Now, the difference between evaluated and unevaluated actions may seem very minor, so I think it's important to compare it with something more tangible. For example, a good analogy for actions are explosions. In real life, we do need to blow things up from time to time, maybe to destroy an old building or to power a car engine. Now, explosions are dangerous and unstable, so we don't want to manipulate them directly. Instead, we prefer to use something like dynamite sticks, which will be the equivalent to I/Os. They are something that can trigger the explosion, but as long as we don't ignite them, they are safe to work with. This means that we can lay them down, wire them up, maybe set some timers, and then once everything is set up correctly and tested, we press the button and boom, the explosion occurs. This is the equivalent of calling unsafe run on I/O in the main of our application. Now, there are fantastic benefits to working with code that is not yet evaluated. We can easily write powerful error-handling combinators and retry logic because we control when the evaluation occurs. This means that we can wrap the evaluation within a try-catch block or re-evaluate the code if required. Similarly, we control where the code runs. We can execute it in the current thread or dispatch the evaluation to a thread pool. As we saw at the end of this chapter, this enables powerful concurrency methods such as parzip or partraverse. As I mentioned in this chapter, there are several open source libraries which implement the I/O pattern. The most popular ones are Ch05, Monix, and Zio. And these libraries go much further than what we have covered in this course. Here's a few examples. First, resource management. For this, they let us package initialization and tear down functions together. For example, opening and closing a transaction. This means that once you access a resource, we are guaranteed that the closing operation will be executed at the end, even if an exception or interruption occurs. So this is like a functional and composable finally block. Second, they integrate with streaming libraries such as FS2. For example, with our flight aggregator, we could return a partial result without waiting for all data providers. And then we will update the stream as more results become available. I/O libraries also provide efficient scheduling methods, which means we don't do any more thread.sleep. Additionally, they let us simulate time passing, which is crucial if we want to test time-based logic, such as a retry with an exponential backoff. Last but not least, I/O libraries provide an extremely efficient implementation for actions. This is achieved by a heavily optimized encoding, but also by providing best practices in terms of thread pool configuration. On this topic, I would like to mention that I chose to manually pass an execution context to all concurrent methods of our I/O implementation. This was for the sake of simplicity. However, modern I/O implementations, modern I/O libraries, have a much more user-friendly approach to inject execution context. So to summarize, I strongly encourage you to either use Ch05, Monix, or Zio in your job. They are safer, faster, and more user-friendly than Future. The only inconvenience is that they are not part of the standard library. But I would argue that this is a good thing. Scala futures were a fantastic improvement over Java futures 10 years ago, but because they are part of the standard library, they haven't evolved that much. Now, the question I get the most often is which I/O library should I use? Personally, I've used all three and they are all fantastic. My advice is just pick one and stick to it. There are a few differences here and there, but overall they are pretty similar, and they are all extremely well maintained. Cool, so I hope you enjoyed this chapter, and don't hesitate to share your feedback and questions either by commenting below this video or in Slack. Have a great day, everyone.